Let's start off with the substitution method of definite integration. So we have already used substitution method in indefinite integration, and let's see how and what are the changes when we use this method in definite integration. So let's start off with the first question. So let's say the first question is you have integration 1 to 3 cos of log x upon x dx. This is the question. Okay, so let's start off with it. So obviously I can see log x and I can see 1 by x. So I'll put log x as t. So I'll put log x equal to t. So you can put log x as any variable. I'm just using t. So log x is t. Now we take derivative. So 1 by x dx is equal to dt. Now the most important part in definite integration is when you substitute, you have to change the limit. So what you do is when you put x as 1, so t becomes log of 1 and log of 1 is 0. So t is 0. And when you put x as 3, you get t as log of 3. Okay. So what will happen is my integration will become 0 to log 3. Okay. The limits have changed. 0 to log 3 cos of t dt. Right? Because 1 by x dx, so 1 by x dx becomes dt, this becomes t, and the limits have changed. Now you can just easily integrate. So now I will be equal to, when you integrate, integration of cos is sine, so you have sine t and the limits 0 to log 3. You put the limits and you get sine of log 3 minus sine of 0. Sine of 0 is 0, so the final answer is sine of log 3. Right? So this was the first question. Let's start off with the second one. So let's say the question is 0 to pi by 2 square root of sine theta cos of cube theta d theta. Okay, let's start off with this one. Now I can see sine, the derivative of sine is cos, and so I can just put sine as t, right? I can just see that clearly. It seems sine theta equal to t. So now the derivative is cos theta d theta equal to dt. Now what about the limits? So when x is, so here it's theta. So when theta is 0, so t will be sine 0 and sine 0 is 0. And when theta is pi by 2, sine pi by 2 is 1. So t is equal to 1. I've got the limits, but I have to just manipulate this because I have cos theta d theta and here I have cos cube. So let's just make some changes here. So what I'll do is I'll write 0 to pi by 2 root of sine theta, and see what I'll do. Cos cube I'll write as cos square, and cos square I can write as 1 minus sine square into cos theta. So hope you got this step. Okay, cos cube I've written as cos square. This is cos square into cos. Cos square I've written as 1 minus sine square. Okay. Now why we have done this? So now we can easily substitute all the values. So the limits are 0 to 1 root of t 1 minus t square dt. Now it's very easy, you just have to integrate. Now this will be root t minus t raised to 2, t raised to half. When you add up, you'll get t raised to 5 by 2 dt d theta. Now you can, so in fact, just a small error. This is actually t, right? Because we have substituted. So this is dt. Okay. Now t and the limits are 0 to 1. Now t raised to half. So the t raised to half will be t raised to 3 by 2 upon 3 by 2 minus t raised to 5 by 2 plus 1. So that will be 7 by 2, 7 by 2, and the limits 0 to 1. Now you can just put the limits, and that would be 2 by 3 minus 2 by 7. And you can take the LCM and you can get the answer. Okay, right? So hope you got this part. Let's try one more question. Let's say the third question we have as integration of 0 to pi by 2 sine of 2x tan inverse sin x dx. So sine 2x, now what I can do is for sine 2x, what I can think of is I can write sine 2x as 2 sine x cos x tan inverse sin x dx. Now I can easily put sin x as t. What about the limits? When x is 0, t is 0. When x is pi by 2, t is 1, right? Now what I can do is I can write this as 0 to 1. So see, sin x is t. So this is 2t tan inverse t into cos x dx, right? Because sin x is t, so derivative is cos x dx equal to dt, right? So this will be dt. So now the question becomes 0 to 1 to t tan inverse t dt. Okay. Now, in fact, now we'll have to use u into v rule for definite integration. So that we'll do in the coming lecture. So you can keep this one as pending, and you can write here uv rule to be learned in the next lecture. So this was only the main part here for discussion was only substitution, how we substitute in definite integration. And once we substitute, we change the limits. And once we do that, then it's normal integration where you integrate using any of the methods. And here it's UV rule. So in the next lecture, we'll continue from here. We'll use UV rule from here and we'll solve this question. Okay. And till next time, take care. Bye bye.